All right, I'm going to do one more problem. I'm going to go through number 3. And in number 3, we have this one in factored form. So we've already done a standard form, we've done a vertex form, now we're going to do a factored form. So I want you to notice that this is a times x minus p. So p is -7 because plus 7 is subtracting a -7, and x minus q, right? We're going to go through and we're going to find the x-intercepts easily from that factored form. That's the beauty of the factored form, is you can find the x-intercepts really easily. And you can do those first if you want to, right? Or you can do the y-intercept first. You can do these in whatever order, but do the easy parts first if you'd like. So for the y-intercept, we replace the x with 0. So we find 0, comma f of 0. So let's find out what f of 0 is. F of 0 is going to equal the negative of 0 plus 7 times 0 minus 1. So that's 7 times -1 is -7. The opposite of that is +7. So my y-intercept is going to be 0, comma 7. Vertex, I'm going to find the x-intercepts next. Okay, so for my x-intercepts, I'm going to leave a little room over down below for my graph. So for my x-intercepts, here's the beauty of the factored form. That is going to equal 0. When will that equal 0? When x plus 7 equals 0, or when x minus 1 equals 0. So we should be able to see the x-intercepts very easily from the factors. One of them is x equals -7. One of them is x equal 1. So for my x-intercepts, I'm going to have -7, 0, and 1, 0. Now, let's review how to find that vertex. So that vertex is going to happen halfway in between my x-intercepts because of the symmetry line. So to find out what's halfway in between, to find the x-coordinate of the vertex, we can just average the two x values, because it has to be halfway in between, and averaging gets us halfway in between. -7 plus 1 is -6, and -6 divided by 2 is -3. Okay, so we have that. And then to find the k value, let me just really quickly shut the door here. All right, sorry about that. So we've got the x-coordinate of the vertex using the h notation for that. So x-coordinate of the vertex is -3. We plug that back into our function to find the y value. So we have the negative of -3 plus 7 times -3 minus 1. And we get, when we do the math here, the negative of 4 times -4, which is +16. So our vertex is going to be -3, +16. Our axis of symmetry is going to be the vertical line, x equals h. Direction of opening is going to be down because a is -1. That vertex is going to be a maximum because my parabola opens down. So we have a maximum point at the vertex, and that maximum value is going to be y equals 16. Our domain will be -infinity to infinity as always. Our range is going to be from -infinity up to a largest value of y equals 16. And then we'll draw a sketch of our graph, and we'll be done. So we got to go up pretty high. We got to go as high as 16. So we'll leave very little space down below and a lot of space up above. So we have -1, -2, -3, -4, -5, -6. We're going to go over to -7 for our other x-intercept. And we'll go 2, 4, 6, 8, 10, 12, 14, 16. Oh, could have used a little better scale there. It's not very evenly spaced. Oh well, that's okay. And I'm going to change colors to do this graph. So I'm going to put my intercepts on at -7 and over here at +1. I should have put a +1 in there. I'll do that. That's my +1. Back to the red. Okay. We've got our intercept. Let's see, 2, 4, 6, 7 is halfway between 6 and 8. We have our vertex at -3, +16. So we'll go out to x equals -3 up to y equals 16. Our graph is going to be just a little bit distorted because we didn't use the same scale on the x and y axis. And we'll draw our graph. And there's a sketch of our problem. And that is example 3.